Okay, let's talk now about acid and bases. These acid and bases, like salts, they dissociate in water. When they are dissolved in water, they will turn into electrolytes. Think of electrolytes as ions, whether they are positive ions or negative ions. That's what happens when we put acid or a base in water. And in water, they can change the property of the solution or the property of the water they are dissolved in. So let's see some differences between them. Acid is pretty straightforward comparing to bases. Acid, by definition, is any substance that releases hydrogen ions into a solution. So for example, one example of an acid is hydrochloric acid. When I put HCl in water, it will break into hydrogen ions and the chloride ions. So what does this mean? It means that I got hydrogen ions into the solution. Why? Because of the acid. So whenever I put acid in a cup of water, it will break down into hydrogen ion and the other compound. And this is extremely important in definition of acid. Now, sometimes you will find saying that they're giving protons. Basically, if you remember hydrogen, so this is the smallest and the cutest atom in nature because it has a proton and it has electron. So when it loses its electron, like in case of HCl, okay, what it remains with is a proton, and the proton will display a positive charge. Okay, so proton or hydrogen ion basically is the same thing. Okay, so in case I'm saying proton or hydrogen ion, don't get confused. So basically acid is any substance that will release hydrogen ions or protons into a solution. Base is the opposite. It's a substance that will take the hydrogen ions. It's a substance that will take hydrogen ions in the solution. So it will absorb. Let's assume that there are hydrogen ions into this cup of water. And now I'm adding the base. These hydrogen ions will get attracted to the base. And they will form more water molecule. Okay? So base is anything that is accepting hydrogen ions that already present in the solution. And that usually result in water. An example, you will wonder where is this OH negative is coming. Basically, it's coming, for example, like in NaOH, okay? NaOH, so let's say, for example, here, I have, let's say I have a cup of water, okay? And I already added, let's assume that I already added HCl into it. So I have now hydrogen ions. Okay, now let's add NaOH to this cup. Remember, NaOH will break into sodium ions and the OH, the hydroxyl group. This OH will get inside and basically we will have hydroxyl group negative and hydrogen ion positive, and this would result in H2O, water. So in this case, the base here took these hydrogen ions from the water, removed them. Basically, it's re-emerged them or like recombined them into a water molecule. So that's why they were drawn out or taken out from the solution. Uh, if you want it in another way, let's assume that in a cup of water, for any reason, we have like 3 or 4 or 5, it doesn't matter the number, of hydrogen ions. Okay? And I put NaOH into this cup of water. And I see the reaction. After the reaction is done, I'm counting how many hydrogen ions I have, and it's only 1. So where are the other 4? All taken by the hydroxyl group. And that's why it's a base. Why? Because it takes hydrogen ions from solution. This is the base. Now, we saw this is like one example. There are the bicarbonate is another example. Ammonia is a third example. All of these compounds can take the hydrogen ions from the solution. Now, why is it important to talk about hydrogen ions? Because it will determine the pH. The pH is the acid-base concentration, and pH is a homeostatic issue. So this is like a homeostatic variable that it needs to be maintained within a range in our body. Okay, usually the range is neutral, so around 7.4, 7.45, something like this. Okay, so this is the ideal environment of the pH in our body. Now, if we drop the pH, it will turn into more acidic. If the pH increased, it's more of a base. The values goes from 0 to 7, or just below 7. All of these are acidic values. The more lower value is the more acidic. And for the base, the values goes from 7.1, let's say, to all the way to 14. And the higher the value, the more basicity of the solution. For example, so the liquid drain cleaner is like pH 14. The battery acid is like pH 0, extremely burning. A lemon juice, vinegar is around 2. Okay? So this is the pH. However, I need you to remember that pH is referring to the concentration of hydrogen ions. That's what the pH measures. Now, when we are saying pH is more acidic, it means more hydrogen ions in the concentration, in the solution. Whereas if the pH is base, it's less hydrogen ions. Why is that? Why with low pH we have more hydrogen ions? Because it's turning to be acidic. What's the definition of an acid? It gives hydrogen ions. So that's why we will have more hydrogen ions. And here the opposite. Why there is less less hydrogen ions? Because the definition of the base, it takes hydrogen ions away from the solution. So with the more base, it means that more hydrogen ions were taken out or taken away. Okay, so keep this in mind, that the relationship with the concentration of the hydrogen ions is inverted with the scale of the pH. So the lower the pH, the more hydrogen ions. The lower the pH, the more hydrogen ions. The higher the pH, the less hydrogen ions. Keep this in mind. Now, if we want to react acid and base together, that will give us salt and water. And that's exactly what we explained earlier. It's Na plus OH minus plus hydrogen ion plus Cl minus. The base will take the hydrogen ion and that will form water, whereas the chloride and the sodium would form the salt. And usually the pH in this case will be 7, so they will neutralize each other when we are reacting acid and base together. Now, there are other types of solutions that can act as an acid or base at the same time. Usually these are weak acids or weak bases, and we call them buffers. So it's a solution of a weak acid or weak base and its conjugate base or conjugate acid. It depends on whether it was weak acid or weak base. Okay, so it can prevent, and this is the main function of buffers, it prevents large changes in the pH. It resists pH changes in solution. So it prevents the pH from either dropping or increasing. And this is extremely important because, as we said, pH is a homeostatic issue. In our body. So we need to maintain it. We need to maintain a certain pH. So in our body, we have a lot of buffers. Not really a lot, like 2 or 3 buffer systems. The main one is the carbonic acid bicarbonate system, which is this one. This is the carbonic acid. In this case, if it's moving to the right, it's giving me hydrogen ion, so it's acting as an acid. Okay, and if it's moving back, it's acting as a base, because it's taking the hydrogen ion back to the bicarbonate. Okay, so if it's breaking, that's an acid. If it's taking the hydrogen ion, that is a base. Okay, I will stop here. I will make a new video for the organic compounds.